So we've got this cannonball fired at an angle of 40 degrees above the horizontal. Okay, so it goes like this, and then we know that it's going to follow an arc that will allow it to encounter the ground over there. Okay, we're trying to find the horizontal distance that it travels. So you got to write down all of the stuff we know, separate it into vertical and horizontal parts. Okay, we know that this is 40 degrees, and we know that this is 140 meters per second. Okay. So what we have to remember is that this makes a triangle where the two sides, okay, this side here and this side here, represent the vertical and horizontal components of the projected velocity. Okay, so this will be v horizontal, which is constant throughout the entire flight. And this will be the initial vertical velocity, because obviously that's changing because of gravity. Okay, so if I want to find VI, it's the opposite side of this triangle. So that'll be the sine of 40 times 140 meters per second. Okay, so 89.99 meters per second, and that's going to be positive. Okay, we know the acceleration is negative 9.81 meters per second squared. Since the question doesn't specifically say there's a height difference between the launch and impact points, what can we assume VF is? Not zero, no. Remember, what goes up must come down. Same as the initial, but negative, right? Okay, so we got to remember that. As long as they don't mention there's any height differential, then that is a safe assumption. Okay, if there is a height differential, then it's not, but we probably won't deal with too many of those. All right, so we know that VF then is negative 89.99 meters per second. Okay, horizontally, we can calculate V horizontal. Okay, it'll be the cos of 40 times 140. Okay, so 107.246 meters per second. All right, I am looking for first the horizontal distance, then I'll look for the maximum height after that. So in order to get the horizontal distance, I need time. Okay, can I find time with the vertical information? Okay. Are we almost always finding time in a projectile motion question? Yeah, it doesn't really matter which type, whether it's projected horizontally or projected at an angle, time is important. All right, so time will equal VF minus VI over A, so that'll be negative 89.99 minus 89.99 divided by negative 9.81. Okay, so we can shortcut that a little bit. Okay, we'll just go 99 times 2 divided by 9.81. All right, so this thing is going to be in the air for 18 seconds, right? So it's in the air for quite a while. It's going to travel a long way. Okay, so we know our time is 18 point whatever seconds. Now we can calculate D. D equals V times T. So our 107.246 times the time. This thing travels 2 kilometers. Okay, according to significant figures, it's going to be 2.0 times 10 to the 3 meters. Okay. Okay, and that's not unrealistic. Okay, modern artillery can fire much further than that, several hundred kilometers sometimes. Okay, it all depends on how much powder you're willing to put into the cannon. Okay, the more powder you put in, the bigger the explosion, the farther the cannonball will go. All right, everybody follow so far on that? Okay, the other part of this question was calculate the maximum height, which we know happens right here. It'll be our vertical displacement at the exact halfway point. What is VF at that point? 0. Okay, that's at the top of the flight, okay, where it's going, where it's just starting to turn around and come back down. All right, so VF is 0 meters per second at that point. Everything else stays the same, okay? We just have a new VF. VI is still 89.99. Acceleration is still 9.81. All right, so now we can use this formula. VF squared equals VI squared plus 2AD. We're looking for D and we have all the others. All right, so we'll have VF squared minus VI squared over 2A equals D. Okay, so that'll be 0 squared minus 89.99 squared divided by 19.62. Okay, sorry, and that's negative. All right, it's going to reach a maximum height of 4.1 times 10 to the 2 meters to the right number of significant figures. Okay, is that pretty high? Okay, it's almost half a kilometer, okay, so it's pretty high up. Okay, is that ringing a bell for everybody? Okay, again, that is typically what I would ask, okay, on like a unit exam or something like that. Okay, so we've got this thing, it's thrown into the air. We don't know what angle it's thrown at, but we know that this is 35 meters per second. Okay, so this angle here is unknown. It's just theta. Okay, we know that it's going to land horizontally 70 meters from where it's fired. It's going to be in the air for 2.5 seconds. Okay, vertically speaking, we know the acceleration. And that's it. What can I find with the horizontal information? Okay. Right, I can find the horizontal velocity. Okay, so I'm going to go 70 over 2.5 because it's just d over t, right? So 70 over 2.5 tells me that it's 28 meters per second. All right, every time we've done one of these projected at an angle questions, we've said this side is the horizontal velocity. And it's 28 meters per second. If I have two sides of a triangle, can I find the angle? Okay, does that mean that I could find this side of the triangle? I could, okay? I can either use like Pythagorean theorem in reverse, or I can find the angle and use trig, whichever, okay? Probably the easiest way, since I'm just wanting to find the angle, is just to use trigonometry here, okay? And go that this is the adjacent side, so the cos of theta is going to equal 28 over 35. Okay? And then if I want to find theta, it'll be cos to the minus 1 of 28 over 35, and that'll give me my angle. All right, so the angle's 37 degrees above the horizontal. All right, everybody okay with that one? All right, a little bit tricky, but it's basically just backwards of what we've been doing. Anybody need that one anymore? Okay. Try this one. This is about as tough as they get. Okay. We're looking for the projected velocity. That's the hypotenuse of that first triangle. Okay. We know it's going to travel horizontally 30 meters in 10 seconds. So we don't know the angle. We're looking for this side of the triangle where the question mark is. Okay. And we essentially know nothing other than acceleration for the vertical part anyway. For the horizontal part, we know we know D and T. Here's what we have to realize about this question. Okay? And it's something that we've done a whole bunch of times because it involves our Science 10 acceleration formula. since this thing is going to be launched and impact at the same height, VI and VF have the same magnitude, but different directions. Everybody okay with that? Okay, so we know then that this formula, which is the one we always use, okay, we know two parts of it. We know acceleration is negative 9.81, and we know this. But we also know that these two numbers are equal, but opposite in direction. So instead of writing it as VF and VI, which implies they're different numbers, I'm going to write it like this. Did I just essentially make a 4-variable formula a 3-variable formula? And I know 2 out of the 3, don't I? Okay, so on the top of this, what's negative V minus V? Negative 2V. All right, so really what I'm saying here is that acceleration equals negative 2V over T. And I know A and T. Now I can figure out this side of the triangle. Once I know that side of the triangle, I can figure out the projected velocity, because I'll be able to find the angle and the hypotenuse, because I'll then have two sides. Okay, I'm going to find V horizontal here just by going V equals D over T on this side. Everybody follow me there? Okay, so it's a bit of a math trick, but okay, it's obviously it's an insight that we have to be able to figure out. All right, so A times T divided by negative 2 will give me VI. All right, so that's going to be negative 9.81 times 10 seconds divided by negative 2. So we should be looking at 49.05, I think. Is that right? Okay, so we got 49.05 meters per second. So that's going to be this side. Okay, V horizontal is going to be 30 over 10, so 3 meters per second. So this thing was fired almost straight up, right? I mean, this side, the vertical side, is way bigger than the horizontal side, right? So this thing was thrown almost straight up in the air. Okay, so if we want to find that projected velocity now, we do a Pythagorean theorem calculation. All right, so it's basically the same. It's 49.1 meters per second. And then the angle, I'm going to use tan because I have the opposite and adjacent side. So 49.05 divided by 3, 87 degrees or 86.5 degrees. So it's almost straight up in the air. Okay, everybody kind of follow me on that one. Obviously, that's more of a dirty trick kind of question, okay, that I probably wouldn't put on a unit exam, but it's still something that we should work through and kind of see how it happens. All right, any other questions on that one? Okay. Anyone still need it up here? Okay, what I want you guys to work on now in your kinematics digital workbook, okay, from the thing there, the last page or the last couple of, not quite the last page, but there's some projectile motion questions in there. Okay, I think there's like 10 or 12 of them. I want you guys to work on those right now, so I'll call those up. Okay, so starting on, what page is this? 9. Okay, kind of the bottom third of page 9 is where the projectile motion problems start. Okay, the answers are there, so you can check if you're doing them right as you go. Okay, let's have you guys work on those for a while, and then if there's questions, obviously we can go over them together. Okay, so let's look at number 1 here. So it's thrown horizontally at 10 meters per second off the top of a 90-meter building. Okay, and we know vertically speaking that the building is 90 meters high. The acceleration is going to be 9.81 meters per second squared. Since that's all negative, I'm not going to change it. And what's VI here? 0. Okay, horizontally, right now, all I know is 10 meters per second, and I'm trying to figure out what this horizontal distance, or sorry, displacement is going to be, okay, as a result. So what can I find with these three pieces of information? Time. Yeah, I'm going to use d equals vi times t plus 1/2 at squared. This is 0, so I can get rid of it. All right, solving for t means that I bring half of a over to this side, and then what do I have to do? Square root. Okay, so we square root, and we got 90 meters divided by half of 9.81, so that's 4.905. Okay, and that'll give us our time. Okay, so we got 4.28 seconds is how long it will take to fall all the way to the ground. With me so far? Okay. Now that I know that time, I just have to multiply that by the horizontal speed to get how far it goes horizontally. So 42.8 meters. Okay. That making sense? There's those little things that we do have to memorize. Okay. One of the things we have to memorize is if it's thrown horizontally, VI vertical is 0. Okay. And you know, for the projected at an angle ones, we have to remember that VF and VI are equal if they land and are launched from the same height. There's just a few of those little things that if we forget, it makes the question pretty tough because it seems like we don't get enough information. Okay. All right. Any other ones we need to go over right now? All right, I'll give you a little bit more time and we'll see if any more come up.